All right, guys. Number 20. Um, this one deals with the volume of a cone, and the geometrical formula is given to you right here in the problem, right here. Um, so the volume of a cone is equal to 1/3 pi r squared times height. All right. The question is asking you find the rates of change of volume. All right. So that's probably going to be your dV/dt, right? That's a derivative. If the rate of change of its radius is equal to 2 inches per minute. All right? And they give you this extra information right here. H equals 3R. And that is very useful information, okay? Because that will help us to figure out the rate of change of the volume. All right? So let's write down what we have. We need to find, what do we need to find? The rate of change of the volume. So that's your derivative. You need to find dv dt when um okay when r is equal to 6 inches and when r is equal to 24. So two different problems. All right, two different answers. All right, and we're given, what are we given? We're given the rate of change of the radius. All right, so the radius is changing at a rate of 2 inches per minute. 2 inches per minute. All right. All right, so that's good. We're also given the fact that h, the height of the cone, is equal to 3 times its radius. Interesting. All right. So the height of the cone is equal to 3 times its radius. Now, what can we do here? Well, first of all, so we have all the given information. All right. And we need to find dv dt, all right, when r is equal to 6. So let's write down our volume formula that they gave you. They gave you this. And I write my r's uppercase because I have a hard time dealing with lowercase. As you can see right here, it just turns out funny. So for the sake, I'll just write it as capital R. Okay. Now, if we were to find the derivative of both sides with respect to t right here, you'd end up here. This is a constant, but the problem is you have two different variables right here. So we would end up with something with dr dt and something with dh dt. All right, and that's not given to you in the problem, dh dt. Now you could find it. It would involve some work. All right. So to avoid the hassle, we're going to use this nice gift that is given to us in the problem. H is equal to 3R. That means we're going to make the substitution for H right here and get rid of H right here in the get-go before I differentiate both sides with respect to T. So therefore, I don't have the hassle of first of using the product rule. Now I'm just going to have one variable, which is R. Okay, and I know I have dr dt, so that's good. All right, I don't have anything for dh dt, and if I just differentiate it right here, I would have to use the product rule, and then I would get something in terms of dr dt, which is fine, but then something also with dh dt, and I don't have anything here. Now you could get it, but it involves some work. So we're trying to avoid that extra work. All right. So that's why when you saw the book, the back of the book, Bob made a substitution right here for H. And that's what we're going to do first before we differentiate both sides with respect to T. So here, I'm going to have that. But here, H, I'm going to put H here for H is equal to 3R. So instead of putting H, I'm going to put 3R. Good. And then I'm just going to simplify that. So I'm going to simplify that. And I'm going to have R squared times R gives me R cubed. And these 3's right here, 1/3 times 3, they're just going to cancel out. Okay, so I'm gonna end up with, let me put it the long way. Okay, r squared times r gives you r cubed, and then these threes are gonna cancel out each other. So v just ends up to be pi r cubed. Good. So some of you are saying, well, why? Well, I eliminated that h for one. So now I'm just going to differentiate both sides to with respect to t, and I'm good to go. All right. So here's where we're at now. We're gonna have we're gonna have to differentiate both sides with respect to t. The left side is easy, just dv dt. That's a constant. So I'm gonna put 3 in front. I'm gonna have 3 pi r. Take 1 from the 3, you get 2 times the derivative of r with respect to t. So I'm going to end up with dr dt. Okay? Now, what's the question asking us? Well, find dv dt when r is 6. So I would have a substitution for r right here. And I also have a substitution for dr dt, which was given. Okay? So this makes our life easy. So we had to use this given information right here. All right. This was given to us for a reason. All right. So therefore, when r is equal to 6 dv dt, and it's merely arithmetic now. All right. It's just a matter of plugging in numbers and getting your answers. So we have 3 pi r squared. Well, when you square 6, you get 36 times 36. So let me use parentheses right here. Then times dr dt, that's a constant rate, which is 2. Okay? So multiply all those guys out together, and we should be getting 216 pi. Now, what's the units? Well, in this case, our units was inches, and we're dealing with volume. So volume, it would be inches, what? Cubed. Inches cubed per, was it seconds that were given? No, this time the time was given to us in minutes, so make sure you have the correct units. You put minutes. So what do we say? Our conclusion statement would be the rate of change of volume when r is equal to 6, precisely when the radius hits 6, the rate of change is equal to 216 pi inches cubed per minute. Now you could get an approximation answer, but this is an exact value, and that's what I want, so you could just leave it just like that. All right. And similarly, you do the same thing when when r is equal to 24. We're answering B now. When r equals to 24, you merely just plug in 24 here for r, and I'll let you do the math here, but the book came up with an extremely big number, 3,456 pi inches cubed per minute. Okay, so that's all arithmetic there. You can definitely work yourself. Once you get this related rate equation right here, it's all a matter of just plug and play. All right, and so that's the answer for that one. When the radius hits 24, look on this rate of change. I mean, this thing is speeding up real fast. All right, it jumped from when r was 6, it was just that, and when r became 24, it jumped to that. Okay, which is a pretty dramatic increase. Okay, so hopefully that helped you out. Okay.